हेलो स्टूडेंट्स, वेलकम टू माय लर्निंग चैनल आर लर्निंग। आज डिस्कस करेंगे और एक इंटरेस्टिंग क्वेश्चंस के ऊपर जो एमिन चैप्टर के तहत 2026-23 जनवरी पे आया था। क्वेश्चन बहुत ही इंटरेस्टिंग सा है। गिवन बिलो द टू स्टेटमेंट्स। फर्स्ट स्टेटमेंट क्या है? एमिन, दिस एमिन can be synthesized from corresponding dial alkyl benzene using the simpler reagent in the order acidic KMnO4. This is number one. Number two is ammonia, and number three is bromine and alkali. Question two है, this amine can be converted to this compound, dibromo compound, using the reagent order bromine in water, then dilution reactions followed by aqueous 3PO2 treatment, which is a reducing agent or dehydrating agent, or you can say deaminating reagent. Questions को solve करते हैं. This is the structure of that compound CH2 CH2 CH3, and this is the another propyl group. Reaction with acidic KMnO4 which gives dicarboxylic acid, which on treatment with ammonia it gives amide or diamide, and this diamide on Hofmann degradations reactions, which is bromine and KOH, so amide to amine. This is well known reaction. So statement 1 is correct. Let's see the statement 2. So statement 2 में बोला गया है कि this is the compound CH3 and NH2 which on reactions with bromine water. Bromine water is a very reactive brominating agent where both ortho and para positions to aniline get substituted. You can see here are two electron activating group. One is amine, one is methyl. So methyl also ortho and para reacting groups, amine also. But in case of methyl, only plus I effect works and not any other effect. And where is in case of or aniline, plus R resonance work. Plus R effect is much more stronger than plus I effect, increases the electron density in a much higher way than plus I. This type of compounds, reactions take place ortho and para related to NH2, not related to CH3. We will get dibromo compound here and amine, not this one. Remember this. This we won't get. This or tetrabromo we won't get. So this on reactions with NaNO2, this is also well-known reaction. So it will give N2Cl plus minus, and bromo is here, and which on reaction with H3PO2, which is a reducing agent and or deaminating reagent, it will give hydrogen here and bromo here and methyl here. So statement 2 is also correct. Both statement 1 and 2 are true. 2 is the correct answer. So this is one part. Now let's see the interesting, very interesting reactions, which is reactions of alkane with KMnO4, CH3 with KMnO4. Remember, KMnO4 is one of the strongest oxidizing reagent, and it convert to CH3 directly to carboxylic acid. This is one part, but also maybe I can go to next page. So this is carboxylic acid. Whatever CH3 will be there, benzene, that will be converted to carboxylic acid. So this CH3 will be converted to this one in presence of KMnO4, basic KMnO4 in KOH under heating. This is aqueous KOH. So next, Under the same reactions, if it is ethyl, then also it will give the same carboxylic acid. If it is isopropyl, then also it gives the same carboxylic acid, the same reagent. And if it is tertiary group, tertiary butyl, it won't give any reaction. Why? Because to convert either from this or from this or from this, we need an alpha hydrogen atom, which is the utmost condition for this type of reactions. If the alkene group attached to aromatic compounds contain at least one alpha hydrogen, then it will oxidize to give the corresponding carboxylic acid. So all three products will give the same carboxylic acid. If you want to have the mechanism, please let me know. I will discuss in a separate chapter and I will upload it. Based on your request only, I will do the mechanism of how primary, secondary aromatic alkyl group undergo oxidation reactions to give the corresponding carboxylic acid. So this is very important. Now, if a compound, say this one, methyl, ethyl, this is tertiary butyl, and this is isopropyl. What will be the product if we treat with KMnO4 and aqueous KOH under heating? So answer is very simple. Just to check where is the alpha hydrogen. Here there is one alpha hydrogen. Here there is at least one alpha hydrogen. Here also there is at least one alpha hydrogen. So this all will give the carboxylic acid. And this does not have any alpha hydrogen, so the product will be this. So if JEE or NEET this type of question comes, remember this. So this is one of the tricks and also the conditions how KMnO4 oxidized aromatic alkane. The mechanism of all three will be different. Now let's see how this works. This is the extra learning that I am giving you. Suppose this is the compound. So same KMnO4, aqueous KOH and heating. So what will be the product? And product this that this will break from here. So if alpha hydrogen is there, then it will give the corresponding carboxylic acid. So HOCO 1 2 3 4 5 6 7, 1 2 3 4 5 6 7. So this will give the product. Also further oxidize the same KMnO4 basic conditions to give the corresponding acid. It will break from here 1 2 3 4 5 6, 1 2 3 4 5 6. So COOH plus CO2. But this is very rarely need robust condition. This is very unlikely. So this type of reaction may not take place in another normal condition. This is the major product. This is one part. Second, if I give you like this is also very easy. This will give you the first the aldehyde and the corresponding CHO and the corresponding carboxylic acid plus carbon dioxide. If I give you another compound, say this type of compound, contain one primary, one secondary alkene. So this on KMnO4. So it will break from here and from here. So gives the carboxylic acid. So 1, 2, 3, 4. This is the carboxylic acid, and this will be the first carbon. This is the first carbon. This is the second carbon, and here it will be keto plus this part will give the corresponding carboxylic acid CO2 plus this part will give CH3COOH acetic acid. So remember this, in JEE the question may be asked that if this type of compound you do KMNO4, number one carbon dioxide will be the side product, acetic acid will be the side product, this type of 3 4 options will be there, then you have to be very careful because both carbon dioxide and acetic acid will be generated. These can also further go oxidation keto to acid, but that is very unlikely as I mentioned earlier. So this is all for this chapter. There are a lot of examples are there, so I am not going to discuss here. So since the KMNO4 topics is very interesting topics for oxidations and for reductions, lithium aluminum hydride is equally important. So these two reagent you must study thoroughly. थैंक यू. वीडियो अच्छा लगे तो लाइक कर देना और कमेंट्स में जरूर लिखना कि आपको मैकेनिज्म चाहिए कि नहीं. बेस्ड ऑन दैट आई विल प्रोवाइड द मैकेनिज्म्स ऑफ ऑल प्राइमरी सेकेंडरी एंड टर्शियरी alkene, aromatic alkene, how it oxidizes. Thank you so much.